Okay, so this is another example. Anytime we are dealing with a question, first of all, look at it. Every information that you are given, it turn into a diagram as we were discussing, and then you try to simplify the diagram. And you ask, what are they asking you to find, right? And when you know what they are asking you to find, now you have to develop a way to get to what you are trying to find. Okay. So a man pulls a force of 10 newtons on a rope attached to the top of a building. So our point of interest is the top of the building. Let's say A, right? A. And then 300 newtons, so it's like this, right? A rope. So 300 newtons. It's not always that you be given the diagram. That's why at times I take time to draw it. Okay. And asking us to find the vertical and then the horizontal components of the force, right? But here they've given us some part of the question in diagram form. So let's see. Yes, it's here. Meters, rather. Okay, here's alpha. Here's AB, and then this side is 6 meters. One thing you should pay attention to is at times it's possible that the unit on the side should be different. So it's possible that even the 8 to be like centimeters and then the 6 to be meters. Because we are dealing with force in newtons and SI unit of length is meters, it's advisable to make everything meters. So just pay attention to what you're having and then move slowly and then nicely to what you want to get, right? So we want the horizontal and vertical component. I'm doing this again because it's very important. Whenever you're having a system, because we are in a 2D system, the coordinate system is oriented this way, right? Here's x and then here's y, right? These are the positive sides, right? Then anything negative will be here in this way, right? Here's negative x and then here's negative y, right? So meaning that everything that we are doing here per this particular diagram from the question, when you look at it, well, if we align our coordinate system, it's not always that you must draw it, but when you have it in head, you know where you are going, you can just draw everything on it and go forward. Meaning that the y component that we are looking for will be negative, right? So it will be a negative y. The x component that we are looking for is a positive y, sorry, a positive x, right? So you know how to find that we need the angle theta, right? Because we are asking for we are trying to find the vertical and the horizontal component, right? To find the horizontal, which is f of x, we need, looking at it, is in the when it comes to coordinate system like this one, here's x, positive x, here's negative x, here's y, and then here's negative y. Are you okay? So looking at where this force will be, this component will be to positive, right? So nothing, no sign will be there, so positive, right? And then we have the force itself, 300 newtons, right? And then we want the angle. So we have the fx, right? So looking at how the fs is per the diagram, there's the x, right? The fs. So it will be in this direction. It will be here, right? So if there's the origin coordinate system, right? So it will be positive, right? So positive. The f here is 300, right? And then the angle cos theta, right? So they didn't give us angle directly, so we use what we have here, right? So cos theta is the same as adjacent over hypotenuse, right? We don't have the hypotenuse, so use Pythagoras, right? So the hypotenuse, which is the AB, so we need what adjacent over hypotenuse. The adjacent is 8, hypotenuse is AB, right? So 300 times 8 on AB, and we know AB to be 10, right? Because that's how it will be. So AB will be equal to square root of 8 squared plus 6 squared, right? It gives us 100, square root of 100, 10, right? Yes. So that's our AB is 10. So that will give us our fx. So let's see. Yeah, this is 10. One good thing to it that you must be very familiar with the calculator. That way it makes your work smooth, because the calculator is allowed, and then if it's allowed, then you can make use of it, and then help you do your work, get the answer you're looking for. Right. So this is what we're looking for. So 240 newtons, right? To be more precise, I, right? Now we are looking for the Fy. F of y. Looking at the diagram again, this is the origin, right? So if you compare it to this one, let me use red so it's clearer. Comparing the diagram here to the origin diagram, right? To the coordinate system diagram, right? So the y, yeah. So comparing it to the coordinate system here, which is 2D, the y is in this direction, right? So negative y. So this is how what will happen. So the f of y, which is the vertical component of the force, will be this way. First of all, minus, right? Because of the direction. So the first thing is direction, right? So direction here is negative, right? And then we have the force, and then we have the sine, and then the angle, right? So no negative, the force is all 300, right? F is 300, and then we have sine theta. So sine alpha, right? So sine is what's the name? Opposite of hypotenuse, right? So the opposite is because this angle, the opposite is the 6, right? The 6 over the hypotenuse, right? Always remember the negative, because if the negative is not there, it's a whole new something that you've written. Yeah. So let's see. 6. 180. 180 newtons. Horizontal, vertical component, right? So J. Right. So these are the 10. So finally, if you want to find the 4 force, this is what will happen. This F is equal to this actually a small y, I'm right a wall. So y, If we go to Fy, Fx plus Fy. It's the same thing. Even if you change it, it's the same. Fy plus Fx is the same thing. Right. So let's write the Fx first. We have it to be 240 newtons, right? So 240 newtons, right? I minus 180 newtons. So this ought to be 240 newtons. That's I, right? Minus 180 newtons. That's G. Yeah, so this is what's happening. So this is a full description of the force, giving us the direction and whether it's horizontal or vertical. So this is it. So it could even be this way. It doesn't matter. Minus 180 here, right? So far as the G and then the I are attached to them, it's still the same thing, right? 240 newtons, and then the I comes. Just the same thing. Yeah.